I'm going to talk to you about polygons, very basically about polygons, but then I'm going to get into more detail and talk to you about quadrilaterals. And so polygon is a very broad term that just means a shape with many sides. And if you actually look at the root of the words, poly means many and gon means sides. So polygon is a shape with many sides. And by many, I mean 3 or more. The sides have to connect. There can't be anything curved, so like a circle is not a polygon. And it can't come in. And I'm going to try to draw an example. But like this is, I'm sorry, we'll pretend that's straight. But this is not a polygon, okay? So polygon has many sides. They're straight, not curved, 3 or more sides. So again, it's a very broad term. Well, there are specific types of polygons that are named depending on the number of sides that they have. So for example, we have a triangle which has 3 sides. We have a quadrilateral which has 4 sides. Sorry, went too far. A pentagon which has 5 sides. A hexagon which has 6 sides, and an octagon which has 8 sides. Those are the only 5 polygons that I'm going to require you to know. Now there are a lot more different kind of polygons with names, but these are the 5 that I would like for you to know for me for class. Okay? So there's a broad term polygons. These are specific types of polygons. Now I'm going to focus on quadrilaterals. So I'm going to go over what the different types of quadrilaterals are and what it means to be each of those different types of quadrilaterals. All right, the first kind that I'm going to talk about is a square. So by definition, in order to be called, I'm sorry, I said a square, a rectangle. In order to be called a rectangle, there's 3 criteria. The first one is that opposite sides are congruent, and what that means is these sides are opposite of each other. They are, and they need to be congruent or the same length. So if this side is 3 inches, this side is 3 inches. If this side's 10 inches, this side's 10 inches. Okay, they are the same length. All angles are right angles, so you have 4 angles in a rectangle. All 4 of them need to be 90 degrees or right angles. And then opposite sides are parallel. Okay, opposite sides are equal distance from each other at every point. Those are equal distance, that's equal distance, so they're parallel. Okay. If a shape satisfies these conditions, even if it doesn't look like this and it's something that you would think would be a rectangle, then you could call it a rectangle. For example, if I were to show you, and I'm going to use this only because then that way it'll look more straight. But let's say we have this square here, and I am telling you that all sides are the same length. All 4 sides are the same length. Well, opposite sides are congruent, all angles are right angles, and opposite sides are parallel. So by definition, normally you would look at this and say, oh, this is a square. Well, by definition, this is also a rectangle. Okay? Then we have a square, which here we have here. All sides are congruent. All angles are right angle, and opposite sides are parallel. I kind of think of it as it's really hard to be called a square. It's very hard to be classified a square because it's such strict criteria that make it a square. And the main thing is the all right angles and the all sides congruent. Okay, so if you see it this, regardless of how large or small it is, oops, that's not a square. Regardless of how large or small it is, this is a square and this is a square. Okay, but that's the only shape that can be classified as a square or called a square. We have a parallelogram. Parallelogram is a pretty broad one. It's not as specific as a square. In order to be called a parallelogram, opposite sides are congruent, meaning that opposite sides are the same length. Opposite sides are parallel. And opposite angles are congruent. So these 2 angles are the same, these 2 angles are the same. So again, I can look at this shape right here, which is, we would normally look at it and say, oh, that's a rectangle. But by definition, this is also a parallelogram because opposite sides are congruent, opposite sides are parallel, and opposite angles are congruent. So by definition, this is a parallelogram. Yes, it's a square, but it's also a parallelogram. Opposite sides are congruent, opposite sides are parallel, and opposite angles are congruent. In order to be classified a rhombus, all sides are congruent. And I know sometimes it's a little bit difficult to tell. Remember I said you can use your paper as kind of to help you mark off to see which sides are the same. So you've got opposite sides are congruent, opposite sides are parallel, and opposite angles. So this angle is congruent to this angle is congruent to this angle. By definition, that's what makes it a rhombus. The only other kind of shape that you would be familiar with that would be classified as a rhombus is a square. So a square, by definition, because it meets all three of these criteria, is also considered a rhombus. And then the last one that I would like for you to know is a trapezoid. And the only criteria to be classified a trapezoid, other than to be a quadrilateral, to have four sides, is that it has one pair of parallel lines. And these lines right here are not parallel to each other because they're not the same distance from each other all the way up and down. These lines are parallel to each other, so it has one pair of parallel lines. All the other shapes that we've talked about have had two pairs of parallel lines, but trapezoid can only have one pair of parallel lines. So this brings us to the question of how can a square be a rectangle, but a rectangle is not a square. So if you look at shapes, we have a square here, but then we have a rectangle here. This square could be also called a rectangle, but this rectangle cannot be called a square. And if you think about it, the reason is they both have four right angles, they both have opposite sides same length, and they both have opposite sides parallel, which is the definition of a rectangle. But in order to be called a square, all the sides have to be the same length, not just opposite sides. So that's why you cannot call this shape a square. Same holds true. How can all rectangles be parallelograms? But all parallelograms are not rectangles. When you look at here is a rectangle, and then when you look at a parallelogram, which I know I have, there we go. The definition of a parallelogram is that opposite sides are parallel, so that works with the rectangle. Opposite angles are congruent, and opposite sides are congruent. But in order to be called a rectangle, it has to have four right angles, and a parallelogram doesn't have four right angles. And then again, same thing with the square and a rhombus. If you have, here is a square, and then trying to make, here we go, there's our rhombus. Sorry, it's a little bit off. Oops. This is a square, this is a rhombus, and all the sides are the same length on the rhombus, and all the sides are the same length on the square, but for a rhombus, opposite angles just have to be the same length. On a square, all the angles have to be right angles.